So in this question, we're given this tablet in the shape of a cylinder. We know the height, and we know the radius, x. And we're asked, or we're told that the volume of each tablet is 60, and we're asked to find an expression of h in terms of x. So we need to link the height with the radius. So because this is a cylinder, the volume of a cylinder is the cross-sectional area multiplied by the height. So the volume is the cross-sectional area of this multiplied by the height. And we know that is 60. And the area of a circle is simply pi r squared. So this circle area is simply pi times the radius squared. And in this case, we're told that the radius is x. So we can write it as pi times x squared. So our expression now becomes pi x squared h equals 60. And they're asking for h in terms of x. So what we're looking for is h. So we can divide by pi x squared to give us this expression. So this is the answer to our first question. The question then goes on to say, show that the surface area is given by this expression here. So the surface area is the area of the outside of this tablet. So it'll be the area of the top, the area of the bottom, and the area of the sides. So in the top and the bottom are both circular. So that's the top, that's the bottom, and this bit is the curved side wall. So the area of each of the top and bottom is just pi times r squared, and the area of the side wall is equal to the area or the circumference of the circle 2 pi x multiplied by h. So your circumference is 2 pi x, the height is h. If you unwrap this, it'll be a rectangle with length 2 pi x and height h. So if you just multiply those two, that'll give you the area of this rectangle. So this is our area, but it doesn't look like that. And the reason is because we have this variable h, and here we don't have h. So what I think they are suggesting you do is use the expression you found earlier and replace that so that you have an expression with only x in it. So this is your h. Now pi cancels with pi, this squared cancels with x, 2 times 60 is 120, and that will give you the expression that they're asking for. So that's your answer for part B. The question then goes on to say that we're trying to minimize the surface area. So that means we want the minimum surface area. And they also like to use this word, stationary point. So they want the surface area to be minimum. That means that the derivative, the first derivative of the area needs to be 0. So if you remember what the expression for area was, this is the expression that we found. It was given in the question. So we need to differentiate that. Before you do that, let's get rid of the x in the denominator and convert that to x to the power minus 1. Now, to differentiate this, that's straightforward. It's 2 times 2, then you subtract 1, then minus 1 times 20, and then you subtract 1. So differentiating that is easy. And we set it equal to 0 because we want the minimum surface area. And now we need to solve this. And it looks like a quadratic, except that's a negative power. So we don't know how to deal with negative powers. So let's rewrite that as x in the denominator. Instead of having a negative power, let's write it as x in the denominator. And again, we don't like to have x in the denominator. So if you multiply both sides by x squared, that will cancel out. So x squared times 4 pi x will give me 4 pi x cubed. And then x squared times 120 over x squared is just 120. And x squared times 0 is 0. So now we have a cubic expression, but that's easy enough to solve because we can move the 120 to the right side by adding 120 to both sides. And then we can simply divide by 4 pi and then take the cube root. So you get this expression. You can simplify that. 120 over 4 is 30. And that's your answer. So they did say that they wanted an exact value. And when they say exact, it means you need to keep it with any surds, any fractions, any constants such as pi. So basically, don't put it in your calculator. Leave it in this exact form. All right, and the unit for this will be millimeters. So that's the value for x that makes the area minimum. They then said, calculate the minimum value of a. So using our expression from earlier, we can simply take the value of x that we just found and substitute that here and here. And if you do put it in your calculator, you'll find that this is 2.12 millimeters. So if you put that into the expression, you end up, and because they're saying to the nearest integer, you need to round that to the nearest integer, so that's 85, and that's millimeters squared. Okay, so that's the minimum value of a. All you need to do is take the value of x and substitute it into the expression. We're then asked to show that this is a minimum. So this is a minimum and not a maximum. And to do that, you need to show that the second derivative is positive. So when you're asked to show that something is a minimum, the second derivative has to be greater than 0. So let's remind ourselves what was dA by dx. The derivative was this. You need to differentiate this one more time. So the derivative of 4 pi x is 4 pi. And then when you differentiate this, you get minus 2 times minus 120 is 240. Then you subtract 1 from that, and you get that. And the last thing is you take your value for x, which was 2.12, and you substitute it in here. The 2.12, remember, is the value that we found here. So you substitute that in there, and you get this positive value. And because it's positive, we can say, therefore, A is a minimum. All right, so we don't decide that it's greater than 0. We check whether it's greater than 0 by using the value of x that we found. We got a number that was greater than 0, therefore it's minimum. So that's how you solve this kind of optimization problem. I hope you found that helpful.